Okay, hello, students. I am Professor Jong-won Kim at the Department of Mechanical Engineering of Seoul National University. Today I'm talking about the dimensional tolerance and related fitting system. Uh, Actually, my first question is that since I believe that you did the homework which I submitted, which I asked you to do at last lecture, is that to make the pin plate and hole plate, okay, according to the drawing which I showed you. So my question is that the hole plate and the pin plate you manufactured are interchangeable with each other. So basically, the two parts should be, if two parts should be interchangeable, first of all, it should be assembled together. It can be combined together, right? So my question is that, so the same question is that, can you always assemble two parts if you select each part randomly? So it means that if you made a part drawing and gave it to the manufacturers, then it is assumed that they manufactured a lot of parts according to your drawing. So let us assume that this was made maybe 10,000, and the pin plate also 10,000. Okay, from among 10,000, you will, if it is at the assembly floor, then technician will select one of them out of 10,000 and hole plate from one from the 10,000. Now, it is selected randomly, and then now, if the assembly technician tries to assemble it, my question is that it can be assembled. It can be joined. It can be joined, right? So, how do you think about it? It can be assembled always. Now, from the size of the hole and pin, yeah, I think that you will know that the hole, the size is from 30.0 to 31.0. 30 to 31. It's a little large comparing to the basic dimension of 30. Okay? And what about pin? Pin is smaller, right? So 29 to 30. 29.0 to 30. So pin is smaller than 30. Hole is larger than the basic dimension of 30. So you will think that since the pin is smaller than the hole, so it can be assembled. Is it true? So whenever you think about that two parts can be assembled, then you have to think about the worst condition for assembly. Worst condition for assembly is the maximum material condition, MMC, maximum material. So if the pin should be maximum material, then pin should be large within the permitted range. What is the largest size of the pin from the permitted range? 30.0, right? So since it is 29 to 30, so 30 is the maximum material condition. Okay, so if the size of pin is 30, then we call it, this is MMC pin plate, MMC pin plate. Now, what about MMC hole plate? Since this plate should be maximum material, it means that the hole should be, the diameter should be smaller. so that it has maximum material. So what is the smallest size of the hole from the permitted range? Since the hole is from 30 to 31, so 30 is the MMC hole plate. So now MMC pin plate and MMC hole plate, the diameter is 30 and 30, right? Now, so it means that if you select, even if you select it randomly, and by chance, maybe it would be very extreme case, rare case. But anyway, MMC pin plate and MMC hole plate is now selected. This is the worst condition for assembly. Now, MMC pin plate and MMC hole plate, it can be assembled. Now, since this is a 30.0 and 30.0, so you have to think about the distance between the center of the pin and also the center of the hole. If the distance between two pins and distance between two holes is exactly same, then it can be assembled. Okay, but what about the distances? Now in my drawing, the distance is 70, 70, just 70. So the general tolerance will be applied. So what about the general tolerance? Maybe I remember. Maybe let's say that just plus minus 0.5. Then there are many chances that the distances between pin and distances between hole will be different. So even if the diameter, since the diameter is 30.0 and this is 30.0 and distance different, so it will not, in many cases, it won't be assembled. It cannot be assembled, right? So what about it? So the hole plate and pin plate interchangeable. It is not interchangeable. So it is not proper for mass production. Mass production is impossible. But because of whose responsibility? It's my responsibility. My designer. The designer's responsibility. The designer made the wrong drawing and pass it to the technicians. So in the manufacturing shop floor, the mass production impossible. Okay, so I'm saying that I'm saying that general tolerance is not enough for realizing mass production. General tolerance is not. Okay, so there should be some dimensional tolerance. Tolerance is necessary. Some tight tolerance should be given to my drawing. Okay. So far you learned the shape description and also how to place dimensions in your drawing. But if you do not understand the concept of dimensional tolerance, which I'm going to teach today, then you cannot generate any proper part drawing which can realize mass production. So this lecture is very important. The concept of dimensional tolerance is very important, right? So, okay. And so interchangeability is the key to mass production. So, and tolerance, there is a dimensional tolerance and also geometric tolerance. The geometric tolerance, I will teach it next lecture. So both dimensional tolerance and geometric tolerance enables interchangeability for parts, so that the mass production is possible. So the contribution of Mr. Ford is Mr. Ford is an engineer, and his contribution to mass production is to set up the tolerance system. Okay, maybe some students think that the contribution of Ford is to generate a conveyor system. So, okay, the conveyor, even if there is conveyor system installed, the interchangeability is not secured, then mass production is impossible. Assuming that assembly technicians try to put the tire into the shaft, and then he found that the tire hole is smaller, so now he tried to enlarge the holes and then assemble the tire into the shaft. Then it would take 30 minutes, even if he's a very nice, skillful technician. 30 minutes is assumed. Then how can the automobile be produced every 1 minute? Okay, so the contribution of Mr. Ford is that he set up tolerance system so that the interchangeability is possible in his shop floor. Okay, all right. So yeah, I'm going to talk about another interchangeability example, which is the assembly of a stamp and its cover. So yeah, maybe if you are the foreign students, maybe you are not the students of Korea or Japan, maybe China. Maybe in United States, I don't think that they are using any stamp instead of a signature. But anyway, in Asian country, we are using many stamps, our own stamp. Our name is engraved in the end of the stamp, and we put it on the paper. And if expensive stamp, it has a stamp cover like this. So stamp cover are protecting my name at the end of stamp. Okay. So now, every time I put stamp, and then I put the stamp cover on the stamp. All right. Okay. Anyway, imagine that this is another some example of assembly of two parts. Now, we assume that stamp covers are manufactured by Seoul company, and its inner diameter is 10 millimeter. In my drawing, I just shape of stamp cover, and then the place dimension of 10 millimeter, just only 10 millimeter. So that then the general tolerance will be applied. And stamp by Suwon company. So the Suwon company will make many stamps based on my drawing. But on my drawing, the stamp diameter is designated only by 10, without any tight tolerance. So just 10. So general tolerance will be applied. Now, my question is that then the stamp from Suwon company and stamp cover from Seoul company, then I'm going to select one of them randomly and try to assemble it. Then my question is that it will be assembled. Okay? It will be assembled. Now, then what are you going to think about? MMC stamp and MMC stamp cover. So MMC stamp means the maximum material. So, for example, the general tolerance may be 10 plus minus, maybe 10 plus minus, maybe plus minus 2. So 10 plus minus 0.2. So the stamp MMC stamp, what would be the diameter? MMC stamp, diameter of MMC stamp. What would be the diameter? Maximum material. So 10.2, right? Stamp. What about stamp cover? Stamp cover. MMC stamp cover. The diameter is smaller, smallest. So 9.8. So 9.8 stamp cover. The hole is 9.8. Stamp 10.2. 9.8 and 10.2. There is a 0.4 millimeter overlapping. Okay? We call it plus 0.4, yes, overlapping 0.4 millimeter. It cannot be assembled anyway. So interchangeability is gone, right? So based on that general tolerance, the interchangeability is impossible. So, okay. And also, another question is that even if you can always assemble them, are the clearances proper? Okay? Maybe the stamp 10 plus minus 0.2, so maybe let's assuming that the diameter of a stamp is 9.8, smaller stamp. And stamp cover 10.2. The hole is large. Yes. So then it can be assembled, right? But, the clearance is 0.4 millimeter. So if I join stamp and stamp cover and hold the stamp in vertical direction, then stamp cover will drop off right away because of 0.4 millimeter clearance. So then the function of stamp cover, the function of stamp cover is to protect the stamp as it is inserted always. But if it is easily drop off, then the function of stamp cover cannot be realized. So also in this case, we call it interchangeability is impossible because the function, the required function cannot be realized. All right? So anyway, the general tolerance interchangeability is absolutely impossible. Okay? So now, this is if you send the draw, if you send out the drawing with the general tolerance, then your stamp covers will distribute it like this. Okay, and also so this is my schematic. So I convert this graph into this type of diagram. So where you see the large M, the stamp cover, the size is 10.0 millimeter. Of course, there are so many 10.0 diameter stamp cover, so I call it large M. And large B is big size. So stamp cover, the inner diameter 10.2, and smaller stamp cover, so diameter is 9.8 millimeter. Okay, it is whole distributed like this. Okay, the size M is the number is largest. Okay, so this is equivalent. And what about stamp? Stamp is that small m, the size of stamp is 10.0, many small m, and B is a big size stamp. So the diameter is 10.2, and smaller stamp, the size is 9.8. Okay? So these two are equivalent. Now, you try to insert both of them, the stamp with the stamp cover. So maybe in case that the small, large B is the stamp cover, and small stamp, the stamp, smallest, 9.8 stamp and 10.2 stamp cover is assembled, then it can be assembled. with the clearance of 0.4 millimeter. Okay? But in contrary, the big stamp with a small stamp cover, then minus 0.4 clearance. So minus clearance, if minus clearance, then assembly is impossible. Okay? So maybe according to this line, around half of them, half of the combination, the assembly impossible. Okay? Even if the assembly possible, since the clearance is large, so the proper function of stamp cover cannot be realized. It is easily peeled off. So there are so many problems in the sense of interchangeability. Okay? I'd like to remind you again that so this whole plate and thin plate, some pieces can be assembled, but the other, if we select the other thin plate, then the assembly impossible. So interchangeability. So this is all the concept of interchangeability. So now I'm going to talk about the concept of dimensional tolerance. Okay. So this firstly the terminology. So these are the placing examples of the dimensional tolerance. Okay. So this is the dimensional tolerance for holes. So in general case, the holes, if you assign tolerance, then to holes, the hole should be large. So frequently the tolerance is larger than the basic dimension 40. And this is a tolerance dimension example for shaft. Shaft is, in general, it is less than the basic dimension 40, so minus 0.017 to, for example, 0.033. So anyway, this is, so the terminology is that we call it upper tolerance limit and lower tolerance limit. So which means that these are upper tolerance limit and these are lower tolerance limit. So in this case, lower tolerance limit is 0 and upper tolerance limit is plus 0.016. And this case, upper tolerance limit is minus 0.017 and lower tolerance limit is minus 0.033. All right, and also dimensional tolerance. This is the smaller meaning of dimensional tolerance. In general, we call it, these are the larger sense of tolerance, dimensional tolerance. But the smaller sense of dimensional tolerance is that it is just the difference between upper and lower tolerance limits. So in this case, the smaller sense of dimensional tolerance, then it is upper minus lower, then it becomes 0.016. In this case, upper minus lower, also the smaller sense of dimensional tolerance is 0.016. So dimensional tolerance is the same. In this case, smaller meaning of dimensional tolerance. It is a permitted range. Dimensional tolerance is always plus value, right? Since it is upper minus lower, so always plus value, and it is allowable range to vary from the nominal dimension. So both cases, the allowable range is 0.016 millimeter, which call it 16 micron. Okay, so in summary, nominal dimension is 40 here, 40 nominal dimension, and dimension tolerance, both cases 0.016 millimeter upper tolerance limit, okay, and lower tolerance limit, which I explained it just before. So this is a terminology. So, so now selecting a dimensional tolerance, the step one. In this case, dimensional tolerance is a large sense of dimensional tolerance. I'm sorry for confusion, but anyway, so selecting a dimensional tolerance, step one is select the tolerance magnitude. Tolerance magnitude. Now, which one is more accurate here? 40 plus minus 0.008 and 40 plus minus 0.08. Maybe this is more accurate, right? Right. Because the allowable range is 16 micron only, but in this case, the allowable range, which is the smaller sense of tolerance, dimensional tolerance, is 160 micron. So 10 times large in this case, so it is more accurate. Now, which one is more accurate? This case and this case. This is the smaller sense of dimension tolerance. The allowable range is 16 micron, and this is just 32 micron. But the nominal dimension is 40, and nominal dimension here 300. Okay. All right. Then, which is more accurate? Which is more accurate? 40 to 16 micron and 300 to 32 micron. Maybe it's confusing, huh? So now I'm going to show you the table 10.1, magnitude of the dimensional tolerance according to the IT class. The IT means international tolerance. International tolerance. IT class. We call it IT class, which we classify the degree of accuracy of the tolerance. So let me see, nominal dimension now, in previous case, the 40 millimeter was the nominal dimension. So 40 is 30, larger than 30 and less than equal to 50. So 40 is in this range. So 40, nominal dimension 40, and let me see, at the time 16 micron, so 16 micron here. So let me go up, and it say that IT 6, IT class 6, okay? So, all right? So the unit is micron, so be careful about it. The micron. Now, the right case was, what about nominal dimension was 300. So maybe this range, 250 to 315. So 300, and then at that time allowable range was, smaller sense of dimensional tolerance was what? 32. It was 32. So let's go up. Also, it is IT 6, IT class 6. So it means that both accuracy is same. IT 6, IT class 6. Okay. So now summarize, the magnitude of dimensional tolerance is determined by the IT class. So 40 plus minus 0.008 is so plus minus, so 16 micron. 0.001 millimeter is 1 micron. So this is plus minus 8 micron. So plus minus 8 micron. So the allowable range is 16 micron, right? 16 micron. 40 to 16 micron is equivalent to the IT class 6. Now 40 plus minus, this is 80 micron, so plus minus, so 160 micron. Allowable range is 160 micron, is equivalent to IT class 11. Maybe in this table, IT class 11 is missing, but in every standard, if you look at the more detailed IT class table, then you can find that IT class 11. Okay. So anyway, please note that there is a dimensional tolerance according to the IT class. Okay. It says that if the number of IT class is large and large, then the accuracy is more broad. Number is smaller and smaller, then the accuracy allowable range is very, very smaller, so very, very accurate. Okay? All right? So 300 plus minus, this is plus minus 0.016, so 1 micron allowable range. The smaller sense of dimensional tolerance, 32 micron, right? 32. 300 to 32 micron is IT class 6. So both are same accuracy. IT class is assigned according to the use of parts. So precise gauge and measuring devices IT class 1 to 4 is assigned. All right? It means that if you try to assign dimensional tolerance, then the first step is to decide how much accuracy you like to assign to your part based on the function of the part. So if you're designing a pin plate like in your previous homework, then maybe you have to use it using knife. So I cannot assign IT class 6, right? Since it is very, very accurate, so you cannot make it by knife. So in this case, maybe this IT class, maybe IT class 18, 16, 18, maybe. Very, very broad, allowable range. All right. So if you're designing spindle or spindle head, which is in machine tool, very precise machine, then IT class 4 is assigned. If it is a precise part for engines and robotics, engines for automobile or robotics, then usually we are assigning the IT class 6 to 9 accuracy. Okay. And if general tolerance, the general tolerance which is assigned by you, the drawing, your title space, the general tolerance is equivalent to IT class 13 or 14, right? So, which belongs to very low accuracy. Okay, very low accuracy. You understand that? So, all right. So, and also now the second step. Now, first step, you decide IT class. Okay. Oh, this part is certain degree of accuracy. So, I will going to assign IT class 7 or 8. Now, first step. Now, second step is how much larger or smaller than the nominal dimension. Okay, which means that in these examples, 4 examples, A, B, C, and D, looking at the allowable range, smaller sense of dimensional tolerance, this is 16 micron, this is also 16 micron, the allowable range is 16 micron, so this is a 16 micron. So all for the IT class 6, first step, IT class 6. Now, even if the IT class 6 are all same, but the difference is that the upper limit and lower limit. Okay, upper limit and lower limit, upper and lower limit. Now, what method would be proper for assigning to determine upper limit and lower limit? Okay, all right? And looking at the upper limit, this is smaller than the nominal size of 40, nominal dimension of 40. This is more smaller than the nominal dimension of 40, and this is larger than the nominal dimension 40, right? So usually this is the whole dimensional tolerance assigned to whole, and this is usually that assigned to shaft and hole. Okay. Anyway. So the second step is how much larger or smaller than the nominal dimension. That is, what standard are you going to assign upper limit and lower limit? Okay. So now, so before I explain more on step 2, let's just assuming a scene at the design office of a manufacturing company. So this is a Korea bearing. Now, assuming that it's you freshman engineer to the Korea bearing. Now, it's you, and it's some senior engineer. So senior engineer welcomes you to his company. So he likes to teach you. Okay. Now, the teaching is that like this: the dimensional tolerance for the diameter of the bearing outer ring is IT class 7, and tolerance limit is H, small h. So this is a long sentence. So this senior engineer do not say like this. He just will say that, hey man, assign dimensional tolerance H7 to the bearing outer ring. Okay? So can you understand? Oh my God, these senior engineers are trying to teaching me the dimensional tolerance, but he do not give me any number. Dimensional tolerance, I assuming that it is plus minus something like a number, but what he's teaching is that H7, small H7. What does it mean? Since you have to understand the meaning of H7, right? He says that regardless of the nominal dimension 160 over 150, he just to say that assign H7, dimensional tolerance H7 to the outer ring. Okay? All right? So you have to understand the meaning of H7. And another case is the Hyundai Motor Company. So it's you, okay? And this senior engineer is teaching you like the dimensional tolerance for the inner diameter of the transmission bearing housing. So this is a housing, and this is a hole. Actually, this is a shaft. This is a hole, housing. Inner diameter of the housing is IT class 8, and tolerance limit is large H. So he does not say this long sentence. He just say that assign dimensional tolerance large H8 to the housing inner diameter housing inner diameter H7, H8. Then you don't know it, then it becomes trouble, all right? Okay? Now he says that since the meaning is that you are going to use the bearing, which is produced by Korea Bearing. Hyundai Motors buys the bearing from Korea Bearing Company, and 160. The diameter is 160. So now that bearing from Korea Bearing Company, that bearing will be inserted into the housing hole. Okay, housing hole. The size is 160, naturally, right? Then he says that he he's teaching you like that. Since the outer bearing of Korea Bearing Company, the dimensional tolerance is small h7, so you assign large h8 to the housing inner diameter. Why? Why h7 to h8? You don't know. And also you don't know h7 and h8. What is it? Okay. Now I'm going to explain it. Once you know it, then it's very simple. So, all right. Okay. So the meaning of the dimensional tolerance is that the Korea bearing, the tolerance limits of the bearing outer ring diameter shaft H7 applied. So what's the meaning of H7 is like this here. Yeah. So I confess that when I was in Daewoo Heavy Industry as a freshman engineer, all people talk about H7, H8, H7, H6, H8. Oh my God, I didn't understand the meaning of H7, so I was so anxious to know it, but most people not willing to teach me, you know. But once I know it, then it's very, very simple, you know. So please focus on me. Now H7, anyway, H7 is equivalent to this upper limit 0 and lower limit minus 0.40, 0.40. Why? And this is H7, 0 and minus 0.035. Why? It's very simple. It's very simple. Now, the secret of H7 is here. Table 10.2, basic shaft system for upper and lower tolerance limit. So now, we are using lowercase letter, C, F, H, J, S, K, S, etc. So please refer to this table. And this table is selected one. And the full table is actually in the appendix 2 of my text, the Korean text. So maybe, or you can find it from any manual. So maybe. Okay. So anyway, it's refer to appendix 2. Okay, table basic shaft system. So now the secret of H7 is here. So now the outer ring was, the nominal dimension was what? 160. 160. So 160 nominal dimension. Let's follow it. 160. 160. So less than equal to 160. So here 160. Then now and where is H? H. So H and 160. The cross point. There was the number 0. Number 0, the meaning is upper tolerance limit, upper limit. So 0 is upper limit. Maybe you can notice that small h or 0 or upper limit. So regardless of nominal dimension or 0 upper limit. Okay. All right. So, so small h is upper limit 0. Then what about lower limit? You have to decide the lower limit. Lower limit is from 7. 7 is what? 7 is IT class 7. IT class 7. So nominal dimension 160, IT class 7. The allowable range is, let me refer to 10. 160, where is 160 here? 160, 120, between 120 to 180, so 160 and 7, so IT 7, so cross point is 40. You know that? 40. So what about it? So upper limit 0 for H, 0, and upper limit 0 and the allowable range is 40 micron. So 40 micron is 0.040. So minus 40 minus 0.040. Okay, so range is 40, right? 7. So you got these two numbers. You know that? So 10H7, so this H is always upper limit 0. So from the same table, 10, nominal size 10, the allowable limit, IT class 7. So IT class 7, so 100, where is 100? Here is 100. And 7, so you got the number 35, so 35 is here. So 35. Okay, minus 0.035. You understand me, right? The meaning of this. Now, the meaning of H8, large H8. Large H applied to the whole because the bearing outer ring is a shaft, concept of shaft. It is inserted. And housing is a whole. Housing, it is some, okay, the whole. So you have to refer to, if you translate the secret of HA, you have to refer to table 110.3, the whole system. So H, large H is here. Okay, H here. So nominal size 160. So let me say 160, 140 to 160, and less than equal to 160 here. So CDD and subsequent H, you find the number 0. Again 0. All 0. But in this case, 0 means low total limit. Low limit. In this case. Sorry. So low limit. 0, 0, 0. Low limit. H. Now, since lower limit is 0, then what about upper limit? 8. IT class 8. So nominal size 160, IT class 8. So let me say 160 and IT class 8 here, 8 here, 160, 63. Okay, 100, maybe 154. Okay, okay, 63, right? So 0 and plus 0.0, 63. 54 plus 54. Understand me? So the number 7 and 8 means IT class, accuracy class, IT class, accurate for meaning the presenting the accuracy. Okay, 8 and large H, small h means determines the number of lower limit or upper limit according to the table. Okay, now you know the meaning of H7 and H8. Okay, so remind one is that then for the H shaft, for H7 bearing, why? In Hyundai Motor H8 tolerance is applied. Why? Why H8 and H8? Why the bearing outer ring, the diameter of outer ring, the tolerance, dimensional tolerance is H7. Then in Hyundai Motors, why Hyundai Motors try to apply H8 tolerance to the bearing housing where that bearing from Korea Bearing Company inserted. Why? What's the relationship between small H7 and large H8? If you know the secret of this, then you can solve the whole concept of applying the dimensional tolerance. All right. Now, for any nominal dimension, for any nominal dimension, 160, 150, it doesn't matter. Assign H7 to all bearings, H8 to all housing holes, then you get this relationship. Looking at H7, since the small h, it's a shaft, and large h, it is the hole. Okay? Shaft and hole are assembled. Then the hole should be large. Okay? So small h, since the upper limit is 0, so always the distribution of bearing is like this. housing in Hyundai Motors, always the distribution of housing is like this. It's larger than 0. Why? The large H, the lower limit is always 0. So, okay? So 160, it doesn't matter. For any nominal dimension, 160, 150, the whole relative relation between bearing and housing hole is like this. Okay? So always can be assembled, since the hole is large than shaft. Bearing outer ring is always smaller than the bearing housing of Hyundai Motors. Always can be assembled. Interchangeability. The first condition for interchangeability. What was the second condition of the interchangeability? Second condition. Once it is assembled, then the clearance should be within certain range, so that the proper function of parts should be realized. Okay? So now, shaft and hole. So now the bearing is inserted into the housing. So once the bearing is inserted into the bearing housing, then the outer ring should be fixed to the housing hole. If the outer ring of bearing is spinning because of the external force, then the function of bearing impossible, right? So it means that once it is inserted, it is assembled, then there should be some tight clearance between the bearing outer ring and bearing housing. There should be tight tolerance so that it cannot slip. It cannot, okay? All right? So this type of the clearance, so let's imagine that as an extreme case, the bearing housing is a little large within the permitted range, so that it is 160 plus 0.063 micron. It is, comparing to the nominal dimension, the hole is a little large, so 63 micron large. And the bearing, in the extreme case, it is smaller than the 160, smaller than 40 micron, smaller. So the maximum clearance is 40 micron to 63 micron, so around 10 micron. The clearance. The largest maximum clearance is around 100 micron. 100 micron is 0.1 millimeter. Very small clearance, actually. So even if 0.1, around 0.1 millimeter clearance exists, the function of bearing still can be realized. So actually, this is a very tight tolerance, very accurate tolerance, right? So even if so nominal dimension smaller, then the maximum clearance also becomes smaller. 50, then 25. Right? You understand me? So for any nominal dimension, the constant relative relationship is obtained between the bearing ring and the housing hole. Okay? So what does this constant relative relationship mean? We call it fitting system. So I will explain. There are so many fit systems. So actually largely five fitting systems, and 3 fitting systems are, and among 5, these 3 fitting system is usually used. So 3-1 is, we call it loose running clearance fit. So I call it just a loose fit, all right? And close running clearance fit, I will call it close fit, okay? And precise locational clearance fit. So I will call it precise fit right now, right? And also, but it is not many cases, but not frequent cases, but there is a press locational transition fit. So I will call it press fit. Okay? And also, lastly, finally, the shrink interference fit. So I will call it shrink fit. All right? All right, 5 fit. What this 5 fitting system means? Loose fit, loose running clearance fit. Loose fit means that it's something like a relative relationship between a desk drawer and desk frame. Okay? Maybe it's not proper example, but anyway, I like to give you some feeling for the loose fit. Window and its sliding guide. Window. Human food and shoes, maybe. Okay. A bowling ball holes in your fingers. Okay. So anyway, the definition is that loose fit, it can be assembled or disassembled freely without any external force. It can be assembled and disassembled without any external force. Then we call it loose fit. Close fit, close running clearance fit. Close fit is the example is that an automobile tire and its axis, a stamp and its cover, which I call it stamp. Mechanical pencil and its lead. Okay? You're using mechanical pencil and the lead is sliding inside the mechanical pencil hole. And our needle and its minute needle, two needles are it has relative motion, but it is fixed on the same center, the needle. So by using a slight force, it can be assembled or disassembled. Two parts are sliding with each other using the other part as its guide. So relative motion, guide, two parts are sliding with each other. Relative motion possible, but sometimes we call it a little tight fit. So we call it close fit. And precise fit, precise rotational clearance fit. Lego blocks, maybe you have many experiences for assemble and disassemble Lego blocks, right? Lego blocks, once it is assembled, then it cannot be disassembled easily. Okay, Lego blocks. If it is assembled easily, then it is not Lego block. It is not function of. It is not proper function of Lego block. A spline shaft and its gear. This is a spline shaft and its gear. So, but you may not use gear and spline. So, spline and gear. The relative motion possible, but it is very precise. The accuracy very required. Tight accuracy is required, even if it's a relative motion. Anyway, bearing outer ring and its bearing housing, like the previous example. So first, by using hands, you have to align two parts accurately. Using hands, even if it is very precise assembly, it should be done by hand. It cannot, if you're using some hammer, it is not precise assembly. Okay, even if you say the precise device, something like hard disk that has to be disassembled and assembled by hand. Okay, even if it has very tight fit, tight clearance, still the assemble, disassemble by hand should be possible. Hands. Okay. Then slide one part carefully into the other to finish assembly. You need quite a strong force to disassemble them. Okay, so I will show you some examples using the blackboard mode. Okay. Now this is a part of the gear pump. gear pump. Yeah, maybe it's a gear pump. And this is a part which is assembled into the core of the gear pump. This is a part. So now, to assemble this part, actually the alignment must be very precise. So it cannot be inserted easily, but if you once you align it rightly, then yeah, sometimes it's different, but difficult. But if you align it very closely, oh my God, very easy. Yeah, it's very difficult. Once it is aligned precisely, then it can be assembled. Now, assembled, right? Assembled. Okay? But the alignment is very important. This fitting system, we say the precise locational clearance fit. We call it precise fit. Okay? All right? Okay. And also, this one is assembled here. This part is a shaft. This is assembled here. But once assembled, then the rotation, relative motion between each other, then we call it, this is cross fit. Okay, cross fit, I'm sorry. This is a cross fit. So, all right? So, the cross fit, it can be assembled with very less force easily, but anyway, the relative motion part of it. Okay, all right. So, but you know, the surface of this part is ground, very precisely machined. This one is also very precisely machined, but still, once it is assembled, the relative motion part of it. Okay, all right. This is a cross fit and precise fit. This is a precise fit. Yeah, precise fit. Okay. If it's once aligned, then it can be assembled. But anyway, if it isn't assembled, you try to put hammer on it, then it is not permitted, right? All precise device can be assembled by hand. So that is precise fit. So I explained the 3 fit. So loose fit, and cross fit, and precise fit. Okay, and the last one is this is not frequently used, but there is a pressed locational transition fit. So I call it pressed fit. Pressed fit is something like a wine bottle, and it's a cork cap, okay? And pinhole and its pin. I explained the function of pin at last lecture. So to assemble, to insert this pin into the hole, then you use a hammer, right? So you have to use a hammer or a press to assemble or disassemble 2 parts. So it requires very, very huge forces to assemble or disassemble. So we call it press fit. And the last one is the shrink fit, shrink interference fit. So a rotor unit of the electric motor and its shaft. Electric motor, the shaft and the rotors where the coil is wound, and high strength bearing and its shaft. So this is you hit a part. So in this case, a rotor unit onto the shaft. Maybe sometimes the shaft is put into the dry ice, very, very cold boxes, and then the shaft shrink. Then very quickly you have to put the shaft and rotor unit into the required position. Then let the temperature going to the ambient temperature. Wait until until it reaches to the ambient temperature, then the shaft becomes large, so that the fit becomes a shrink fit. So the two parts cannot be disassembled anymore once it reaches the same temperature with each other. Or you make the rotor unit in a high temperature. So rotor unit is enlarged, and then get that rotor unit into the shaft and let them reach the same temperature with each other. Then the rotor unit in high temperature it was large, but it shrink again, and then two parts cannot be disassembled. So you heat a part to enlarge or cool it down to shrink and assemble them as soon as possible. So once the temperatures of two parts return to the ambient value, you cannot disassemble them. So we call it shrink fit. So anyway, this table is the summarization of my 5-fit system. So please refer to it. So interesting thing is that to determine H7, H8, the second step, then you have to what was the step one? What was the step one? To designate the proper dimensional tolerance. Step one is decide the level of accuracy. So according to the IC class, class 6, 7, 8, 10, right? First step one. Step two is what? Step two is to decide which fit system you need. Which fit system you need to consider the function of my product. Okay? Fit system. Okay? So if to obtain the desired fit system is selected, so if once you decide the desired fit system, then the dimensional tolerance combination to obtain that desired fit system is selected from the basic whole system as follows. This is a basic whole system. So dimensional. So you assign dimensional tolerance to the whole first. Okay. So among H6, 7, 8, 9, 10. Then once you assign dimensional tolerance to the whole, for example, HA, then if you need a cross fit, then cross HA, then cross fit, then you may assign F7 or F8 to your shaft. Okay. So in the previous example, the Korea bearing company, the bearing was the bearing outer diameter. The bearing was H7, and Hyundai Motors, the bearing housing was large H8. So large H8 here, and then H7 is what? Precise fit. Okay, precise fit. So this is the story. In Hyundai Motor Company, from the brochure of Korea Bearing Company, you found that the bearing outer ring, the tolerance was H7. So it was H7. Then I like to design the bearing housing for that bearing. Then if I need a precise fit, then the story is like this: H7, and here is H7 too. So H7 and H7 is also precise fit. H7 and H8 is also a precise fit. So anyway, H7 and H8, H7 to H7 all cross precise fit. Okay, all right. Okay. Cross fit is H6 to F6 or H7 to F6. or H7 to F7, or combination is realized cross fit. Okay? Cross fit is what? This is precise fitting, but still the relative sliding motion possible. There's a cross fit. Okay? All right. So the answer to now the final answer to the previous final question, why H8 holes to H7 shaft is to realize cross fit. Okay? It's a simple story. So for any value of nominal dimension, the precise fit is obtained from the combination of H7 and H8. So now, don't worry about the size of the product. If the bearing is large 200, but you want a precise fit, then even if it is 200, 250, just apply H7 and H8. That's it. So how simple and how reasonable system it is. So H shaft and H holes result in precise rotational clearance fit. So, so looking at it closely, H shaft, its upper tolerance limit is 0. So shaft diameter is always smaller than and equal to nominal dimension. H hole, its lower tolerance limit is 0. So hole diameter is always larger and equal to nominal dimension. So you can get a minimum allowance of 0, okay, 0, and the average clear average allowance 44 micron and maximum allowance of 89 micron. Okay, so 100 is nominal dimension. Okay. So, all right, return to the case of stamp and stamp cover. How do we select the dimensional tolerance? First, what this system will be okay? Considering the function of the stamp cover, we select close fit. Precise fit is precise fit. It will give the pain to any customer. So if you use the stamp and you try to assemble the stamp cover, but still you need a very precise aligning, then it will consuming many times. Then who will use your stamp cover? So the assembly should be easier than precise fit. But if it is a loose fit, so that once it is assembled easily, but if you reverse it, then the stamp cover easily dropped off, then who will use your stamp cover? So in between loose fit and precise fit, there should be some fit system, which is close fit. All right. So dimensional tolerance combination to obtain cross-learning class fit. Cross fit is 3 options are possible as follows. Actually 5 options. H6 and F6, H7, F6, H7, F7, H8, F7, H8, and F8. 5 combinations possible. According to the table. What table? Sorry, but what table? This table, right? Basic hole system. The cross fit, right? Right? Okay, 5 combination here. All right, 5 combination. Then among 5 combinations, since the required accuracy for the stamp is not high. Yeah, it's a stamp is a stamp. So maybe IT class rather than I class 6, I class 8 is recommended. Since IT class 8 is more cheaper, relatively cheaper than IT class 6, right? So IT class 6 is more precise accuracy, you know. So we decide that among 5 combinations, the mostly loose accuracy is H8 and F8. So you may select stamp cover 10, H8. Stamp cover is a hole, and stamp is a shaft. So large H and small f. So large H8 and small F8. And can you understand F8? What's the meaning? F8 is here. F8. Please refer to the table 10.2. F8. Can you follow me? F8. Let me go to F8. What's the secret of F? Okay, let's go to the table F. F is a 10.2. So sorry, but it's important. Shaft. F. Where is F? Here. F. Okay. F. And A and 10. Nominal size is 10. 10 is where is it? 6 to 10 here. And 8. F. So 6 to 8 F. Minus 13 micron. Minus 13 micron is what? It's upper tolerance limit. Upper tolerance limit. Okay? Minus 13 micron is upper tolerance limit. F. So, okay. So, sorry. But anyway, F. F is here. 13 minus, do not write it minus 13. There was a 13 micron, so minus 0.013 millimeter. So 8, 10 to I class 8. What is the range? Permitted range. Maybe if you're looking at the table 10.1, then it would be say that 12 to micron. So 12 to micron lower, so minus 0.035 micron here. Okay, IT8, the range is 22 micron. Okay, so this is the secret of the dimensional tolerance. So F shaft and H holes result in close fit. Why? Because the minimum tolerance is still 13 micron is secured as a minimum tolerance. Okay, so it is a real. In the precise fit, the minimum tolerance was 0, but now in this case it's 13, and still shaft is smaller than the hole, so it can be assembled. Okay, so average allowance is 35, and maximum allowance is 57 micron. Okay, 22 plus 35, so it becomes 57. Okay. So regardless of the nominal dimension, assign F7, F8 to stamp, H8 to its covers. Then regardless of the nominal diameters, 10 millimeter over 20 millimeter or 30 millimeter, we can obtain a fit system of cross fit for stamp and stamp cover. So big stamp, small stamp, no, doesn't matter. Just F8 and H8 is applied, then you can realize cross fit, which is the required function for the stamp and stamp cover. Okay, and now this is another example. So selection of proper dimension tolerances of the parts of a unit. So now assemble procedure. Use a hammer to insert the bush into the pulley. So bush into the pulley. So it means that the outer diameter of a bush and inner diameter of a pulley, it is hammer, using hammer. So what is it? It is press fit. Okay. So once bush is inserted into the pulley, then pulley and bush will be. It is enough to think that it is one body. Okay. Pulley and inside. Bush inside, and insert the pulley into the shaft, and then insert the key into the shaft groove. Yeah, key is a proper element. So now, the bush is now in the pulley, and that pulley is inserted on the shaft. Then it becomes like this here, shaft and pulley, shaft and bush. So there is some clearance. for what? For rotation, spinning. So this is a what fit system? This is a cross fit. So relative sliding motion possible, even if it is precise assembly. Okay? So put the shaft into the, fasten the bolt into the shaft. This is the finishing of the assembly. So if you finish, then it becomes like this. So pulley is rotating on the shaft. Now, so selection of dimension tolerance. Bushy outer diameter and pulley hole is pressed fit since the hammer is used. So bushy outer fit K6 and H7. K6, H7. What example? Press fit K6, H7, and K6 here. Okay, H7, K6, and press fit. Okay. All right. And the bush is fixed inside the pulley hole, no relative motion possible, and shaft diameter and bushy inner diameter cross the fit since the proper relative rotation is required. So shaft F6 and H7. The shaft is rotating inside the bush. The bush plays a role of bearing to reduce the friction between two parts. So it is a cross fit. So F6 and H7. H7 and F6 cross. Understand? It's very okay. Now the dimensional tolerance for length. Now all we talk about was in radial direction tolerance, dimensional tolerance in radial direction. But in axial direction, also you have to apply the dimensional tolerance. So that in after assembly, the delta 1 and delta 2, that clearance has to be secured. So that the bush has to contact the body rather than the pulley. If pulley is contact with the main body, then the friction will be very high. So the pulley must be contact first to the body. So delta 1, delta 2 clearance has to be secured. So in this case, just the dimensional tolerance is applied by case. Don't think it's very complicated. Just looking at the tolerance, minus, this is plus 0.1, plus 0.2, and pulley the bush minus 0.1 to minus 0.5 to minus 1. Then it is more smaller. So with these three dimension tolerance, if you assemble it very carefully, then you can obtain the positive clearance of delta 1 and delta 2. So, all right? Okay? So in axial direction, don't worry about it. Just case by case. Okay? Now, so this is homework 15. Is write the solution of following two problems in one A4 homework paper. All right? Problem 1, the nominal dimension of the tire hub hole is 80 millimeter. Tire. What is the proper fit system you are going to achieve? And select each dimensional tolerance for the shaft diameter and tire hub hole. What is minimum, maximum, average allowances? And problem 2, the rotor is inserted into the motor shaft by using a press fit. The nominal dimension is 30 millimeter. What is the proper fit system? Oh, I just answered the right answer. Select each dimensional tolerance for the motor shaft diameter and the rotor inner diameter. What is minimum, maximum, and average allowances? This is the example. Okay, now this is the last slide. Only with dimensional tolerance is it enough to secure interchangeability? It's the final test. This is a homework. Can you secure interchangeability with my drawing to distribute it to you for the homework? Still interchangeable? Only the dimensional tolerance, I'm sorry, you cannot achieve, you cannot secure interchangeability of this whole plate and pin plate. All right? You need geometric tolerance. Okay? So the next lecture I will talk about geometric tolerance. So dimensional tolerance and geometric tolerance all together you can secure interchangeability. So next lecture is also very important. Okay? Okay, this has been the